For RCRTech and RCR Wireless News, my name is Sean Kinney, and thank you for joining this deep dive webinar that will conclude the programming for our inaugural AI Infrastructure Week. I think this discussion is going to give you some good perspective on the major themes that we've explored this week and tie together what we've covered related to AI infrastructure and how it's influencing how telecom operators are evolving to support AI for both end users and for their own operations. It's a pleasure to introduce our esteemed panel, Mr. Inanç Çakiroğlu, who's the Chief Information Officer with Veon, Mr. Sridhar Gollapudi, who's the Head of Partnerships and Telco Market Lead with Google Cloud, and Telecom Field CTO with Pure Storage, Mr. Patrick Lopez. So gentlemen, thank you so much for joining the session this morning.
Thanks for having us.
Thank you.
All right. Reminder to our audience, you're able to submit questions. Please feel free to do that throughout the conversation. If you'd like me to direct your question to a particular panelist, if you could please call that out in the chat. And with that, gentlemen, I'd like to maybe start things off by going around the table and getting you to sort of give us a high-level overview of your respective firms' overarching approaches to AI for telecom. I'm specifically interested in kind of the strategic lens that you are using as you work with your customers, or in the case of Veon, as you incorporate AI into your own operations. And just let us know what big picture problems that you're really trying to address first. Maybe we can start with you, Inanç.
Let's start with infrastructure part, the network part, because we are basically talking about, I am coming from the network and the telco origin. And speaking of network and the infrastructure, it is not just the engineering anymore. I really would like to start with that. We have been optimizing our infrastructure, our telco networks through manual efforts, rules, and the configuration for decades. Then we started to use machine learning and the deep learning algorithms for engineering jobs. Now we are basically using AI, generative AI, and now our networks are self-organizing. It's a big paradigm shift for us. And if I need to jump back to Veon, let me give you a couple of insights about the Veon. We are not a typical telco operation. We are not a typical telco company. First thing about us is we operate in underserved markets. These markets are young, growing population, and with some inclusion problems. And to the second, and I believe more important, we are a digital service provider. We don't identify ourselves as a telco operator. We identify ourselves as a digital service provider and a digital experience provider. And AI is a very important part of it. We even don't call AI as an artificial intelligence. There is nothing artificial about it. We call AI as an augmented intelligence. It basically exists into every single part of our company and our operation. So from our perspective, AI is not a feature that you bolt into the company. It is a heart of the operating system of the company. And we have multiple challenges and requiring multi-pillar approach. I will go into the detail, but very brief. There are different opportunities with different values, and it is much more better to address them all rather than just focusing one or on to two. As I said, AI is a very big paradigm shift, and it is not just tool in one area. It is a new way of doing things. It is a new way of executing things and a new way of working. And from our perspective, transformation is about the culture, people, technology, and execution. And the biggest problem is always, it doesn't matter, it is telco operation or any kind of enterprise, it's always upskilling people in the organization and having people with the AI way of thinking. And another one is, it's an organizational development thing, and it's fostering AI as a new culture in the inside of the organization. And this is across all the departments in HR, in finance, sales, procurement, customer service, marketing, whatever you think of. And the other one is you should equip the organization with the latest tools and the technologies. And rather than spending too much time on the strategy side and having endless cycles around the strategy because time is ticking, execution is important. Everything eventually and already changes when you discuss about the strategy. And once strategy is set, execution is a strategy. Those are the main objectives in our AI-based operation.
Excellent, thank you. Sridhar, could you give us a bit of an opening statement here?
Sure. Yeah, I think Inanç, touched upon a few of the things that is important for us as well as we approach the telco market in general. The way we approach our customers and our partners in the telco industry is that there are basically four specific pillars, and they kind of line up with what Inanç already mentioned. Starts with the network and the operation and the optimization of the networks, and then there's the what we call the efficiency pillar, which is making the enterprise, the telco as an enterprise, work more efficiently. And the third part is the customer engagement, and how do we help the telcos do a better job of engaging with their customers. And then the fourth one, which is kind of related to the topic of discussion today, which is all about the monetization piece, which is how do we help telcos grow their revenue. And we see AI infused across all of these pillars. It's no specific, use case or a hero use case. It's, AI is everywhere, right? And of course, as Inanç suggested, it's all about strategy and execution. But in terms of how we see AI playing out across the telco as an enterprise, it's across all of these four pillars.
All right. Now, Patrick, I'd turn it over to you to kind of set the table for our conversation.
Thanks, John. It's hard to follow because I think most of the themes have been addressed. Pure Storage is looking at the evolution of telecom networks to adopt AI from a very particular viewpoint. Obviously, the company has been a leading provider of storage solutions. And until very recently, data was just something that you safeguard and something that you archive. And then every now and then, or even maybe all the time, you would use the data to represent the state of the network at some point in time. But there was no obligation really to have the data pipeline and the data infrastructure to be very high performance, because you would look at it later. What has changed, what we're seeing changing, is that data is becoming much more like the lifeblood of the telecom network. It needs to flow fast. It needs to go to the places where it's going to be processed as fast as possible, so that you can do the things that were mentioned already, but like from network optimization, from prediction of traffic, from creation of subscriber-aware prompts and subscriber-aware actions that allow customers to basically have a better experience of the network and to receive new services. All of this requires basically data to be in near real-time processed throughout the network. And that supposes a change in posture, a change in processes, but also a change in architecture throughout the network, because until now, data was mostly produced at the edge in the access, and then would flow through cascade of dedicated storage to storage that were more data lake or data warehouse, and then to the cloud to be processed eventually. AI and automation, and more importantly, networks that are trying to be as autonomous as possible, require that data to be processed in near real time. So in many cases, that means that some of the data has to be processed where it is extracted. So being able to extract the data from the network function as fast as possible, putting them in a state that can be examined by the algorithmics, so that you can do the optimization, the prediction, and the creation of new services. That's something that we have observed and that we are supporting with basically our real-time data infrastructure.
Excellent. Now, Inanç, I turn back to you. Veon's been very clear, very forward-leaning around AI as a strategic pillar. There on your backdrop, you call out AI 1440, which is the group-wide strategy for AI. Some of the key things here, from my perspective at least, are your use of local language models, your super app strategy, which speaks to your comment about becoming a digital service provider with a focus on user experience built on top of connectivity. But how would you summarize where the group is already using AI at scale, and maybe share with our audience any lessons that you all learned as you moved from pilot to full production?
Yep. I'm always starting with that statement. AI is not something new for us. AI has been always in a place. In the last 3 decades, we have been utilizing machine learning and the deep learning techniques in many areas of our operations. So it is never a new thing for us. But of course, I mean, the before Gen AI, predictive modeling, churn models, recommendation engines, best offers, smart operations, network optimizations, and all other things, they have been already in place. But something obviously changed with LLMs, with Gen AI. Now we are talking about Gen AI and the agentic AI and the much more opportunities. I can group our operation in terms of AI or the usage of AI into 3 different pillars. The one is, of course, automation, the hyper automation in our operational landscape, in customer care, in finance, in marketing, in technical operation, using AI, using automation to get more efficiency and to get even generate some revenue in all the use cases in the sales and the marketing area. Automation is the one pillar and the first pillar. The second one is, of course, infrastructure modernization, self-organizing networks, using LLMs, using LLM-based network operation, network engineer agents. This is the second pillar that we deploy and that we utilize AI in our operations. And the other thing is, I think this is the most important and interesting one, is new service creation. As I already told in the first question, we believe in digital services, and we believe that the AI is a very powerful tool to create better digital services and to enrich these digital services and to enrich the experience through the digital services. And it's a very simple statement we always use. We would like to provide digital services to our customers, and our ultimate aim is making doctors better doctors, making nurses better nurses, making teachers better teachers. So we are doing this through our digital services, and we are using and leveraging AI capabilities to make these digital services more smart, more intelligent. As we speak about the lessons, the first thing, I am always in favor of acting fast, and if necessary, failing fast. I think this is the first thing you need to focus. As you build your technology, or as you build your the AI stack, technology is already changing. And in that sense, velocity actually beats the perfection. The second one is, as I said in the first question, upskilling the employees and creating some mind shifts and making them embracing this new era, this AI era, is also equally important. And use cases are very important. I mean, of course, and the technology is important. Technology is the one of the driver in that sense. But without a good use case, there is no way that you can success. So you should focus on use cases while building your technology stack. And while working on the LLMs, you have to also think about how to use them and how to leverage them and how to actually turn them into a kind of a value addition or the profit or the optimization. I am totally agree with Patrick. Data governance and establishing efficient data pipelines are really important, as important as creating inference and the training infrastructure. The next one would be continue experimenting. You need to focus on the real use cases. You need to build something concrete. You need to build something solid, maybe ready to just launch to the market. But also you should experiment the technology because it is changing fast. And you need to create this skill inside of your organization through the different technologies. And the last but not least, mind the ecosystem. I think AI is a kind of a journey. You cannot just be successful by yourself. You need to create an ecosystem with regulation, with the government, with the public entities, with academia, with startups and the hyperscalers. It's going to be a kind of a win-win play. And it should be a kind of a win-win play. And you should leverage all the existing elements into your ecosystem, because we are talking about new industry, new change in the industry. And it is not something that you can just embrace using your internal, let's say, the organization or the internal network.
Excellent. Patrick, maybe you can expand on that. You referenced this idea of a data architecture being different from a typical network architecture. So operators have some decisions that they need to make in order to really do AI effectively. If you scan your customer base, what kind of patterns are you seeing emerge? What's happening in the field?
Our customers are going through very similar journey. They all at different stages of that journey, but very candidly, anybody at any operator that is being tasked to go and figure out AI starts pretty much the same way. Okay, let's buy some compute, let's buy some GPUs, let's set up some pods, and let's set up an infrastructure to enable basically the usage of large language models for model training, for natural language processing, and then later on to do some inferencing and do some optimization. And that journey always starts with compute, and very quickly they see that it doesn't necessarily meet the expectations that they had in terms of performance. And there are a variety of factors for that. In many cases, the data itself needs to be processed properly. It needs to be cleaned. It needs to be formatted in a way that the engine can consume it. What happens as well is that in many cases, the performance of the compute doesn't reach its target because there are other factors, there are bottlenecks. So they always look at the networking first. So they add ASICs, accelerators to upload the GPUs and the CPUs from the task of the running the traffic. That helps a little bit, but it still doesn't work the way they want. And eventually they all start looking at storage. And eventually they all start to see that spinning disk hasn't been built, designed for bursty, high I/O, low latency workloads that are required in the AI. And inevitably, we start having those discussions, and they start turning to technologies like Flash that have been designed for this type of workload. And then they start figuring out that basically an efficient end-to-end infrastructure for AI requires rethinking a little bit of the network. That motion that I mentioned earlier, which the data used to go from the edge towards the cloud or towards a centralized processing environment, that is changing as well. We're seeing more and more distributed inferencing and distributed AI. We have motions in telecom with AI RAN and Open RAN, basically that dictates or that allow processing of data set nearer to the access in order to optimize and to help with the inference of third party. All of that changes the infrastructure and changes the architecture, because a traffic that used to be mostly north-south or south-north, now you see a lot of east-west traffic patterns. So having an infrastructure that is allowing you to basically decide which data set should live where in your network and be processed where in your network becomes really important.
Sridhar, what's your point of view on these architectural decisions that need to be made? I guess, data gravity is going to inform where AI workloads are run, and we ultimately see a sort of continuum that spans device, edge, regional data center, hyperscale data center. But how do operators get this right and turn network infrastructure from a cost center to an actual growth engine?
Yeah. So as you know, Google has placements across the different endpoints from in the infrastructure, as you know, from the endpoint side, the edge, and of course the hyperscaler, the cloud itself. So from our perspective, the data gravity that we see today currently is still on the hyperscaler, on the cloud side. That's where we see most of the ML processing, if you will, the AI processing still happening. Having said that, as Patrick was talking about, we do see the emergence of shifts from at least some of the workloads going more towards the edge, specifically in the inferencing scenarios. And to that extent, we also have infrastructure play there with our Google Distributed Cloud. And then, of course, in terms of the endpoints with our devices, we do have some, on-device processing enabled on those endpoints as well. So again, we do see that it's going to be in the future more of a distributed play. But as things stand right now, it's the data gravity for sure. And from our perspective, it's definitely on the cloud side. And the reason for that is, again, to some of the points that the prior speakers have mentioned, the gravity is still, the data that's needed to do this processing is still being mostly enabled within a data lake or a data warehouse architecture. That's where, that's how you kind of break the data silos. Today, the biggest problem that we see is the fact that within the telco enterprise, there's different silos of not just the businesses, but the data for that business. And the first problem to solve is to break those silos, right? And that's really where the data foundation comes in. And the cloud is the best place for where the data foundation can be laid. And then, of course, you spread that as in a distributed architecture as more use cases start happening, right? So that's really where we see. And that's how the telcos are really moving forward with making sure that automation processes they're putting in, both from a network operations point of view and a customer operations point of view. That's where the business cases are being currently played out.
Here's one for all of you, and this kind of builds on some of the discussions throughout AI Infrastructure Week, but it's really about the viability of GPU as a service for telecom operators. They have great assets for it on paper. They have power, space, cooling, all of this. I think it's really a question of will they be able to effectively sell it to an end user, but just kind of curious where everybody stands on the outlook for GPU as a service. Inanç, should we start with you, please? If you could come off of mute, please.
Sorry, there was an outside noise. Just I wanted to cancel it. As you said, necessary ingredients for AI is computing power, and the power, connectivity, and the proximity to user for latency concerns or for the use case which requires low latency. And basically, you run AI on the power, cooling, fiber, and the proximity to users. And those kind of things are advantages that we have as, let's say, the telco players. What we see in the market, AI workloads, it's already started, but it's gonna fasten up. They are shifting from big monolithic cloud clusters to the distributed architectures. I'm not saying that it's going to be totally on the distributed side, but there will be more and more use cases and more opportunities on the distributed architectures in the near future. So, basically what we are talking about, inference near the edge, GPUs in the local zones, and the sovereignty constraints and the sovereignty concerns. So what we uniquely have distributed sites with the physical security, all our radio network components, fiber backbones already optimized for the low latency, and it's going to be better and better in the near future. Power diversity in different zones and across the cities. And of course, the real estate grid that we already have because of our backbone and our radio network structure. I don't personally think that we are falling into trap that we had when GPU or the compute power as a service first introduced into the market, because there's something different now for all the reasons that I just listed. And now AI is a real demand. It is not a kind of the compute power for regular enterprise applications. It is a kind of a new industry fact that starting from the single consumer towards the big enterprises, it's going to be needed for different use cases and in different areas. So there is a real demand and a clear monetization for the GPU as a service or any kind of AI as a service demand on the edge. So, and as Veon, what we see that we have markets, we are operating in markets lacking of local hyperscaler capacity. So we are filling the gap in that sense. We have lots of sovereign AI requirements data should reside into the country, and the inference should reside into the country. So we are basically the trusted host for the compute power. And what we observe, a big demand from the small, medium enterprise or the big enterprise market, and from the public sector. So we already have lots of use cases in healthcare, in education, in agriculture, in the fintech. And what we believe is those kind of things are making AI as a service or the GPA as a service as a good opportunity and a good revenue generation stream for the near future for us, and for all also the similar telecom operators.
Right, excellent. Sridhar, I mean, this speaks to your comment about data gravity currently sitting with hyperscale data centers. We're expecting to see sort of a shift towards inference. Inanç raises some interesting points here around who is the customer profile that would use this. And I think historically that SMB segment's been difficult for operators to crack in general, might be particularly difficult to crack when you're talking about GPU as a service combined with some kind of network slice or other dedicated path. But where do you sit on GPU as a service? And then also maybe we can expand that to also include the outlook for operators to make money off of sovereign AI.
Yeah. So what we are seeing is, first of all, is GPU as a service something that's going to be viable in the future? We believe so. We haven't yet seen real, hero use cases for it where we believe, yes, this is going to happen, or this is how it's going to happen. But is it going to happen? Yeah. I think in theory, there's momentum behind it. Also from a 6G standards point of view, there's also momentum going down that path where you have more of these AI workloads specifically being called out to be running on the edge, the infrastructure edge. Again, coming back to the data gravity part of it, we are seeing most of the need for AI, even Gen AI stack, to be mostly running on the hyperscaler side of things. But to Imanç's point, we definitely do see regulatory constraints demanding, I guess, some of these edge use cases where GPU as a service could potentially play out. I think that's going to probably be the leading use case for where you would have someone in a public sector or defense or specific verticals where sovereign AI is really going to be critical or one of the critical needs. That's where I think it's going to be the breakout for when this is going to happen. We're seeing some of that already, where we're seeing from the market, asking for Gemini in a box, if you will, where they want to run, Gemini on the edge. And obviously, we are looking at addressing those kind of needs as well. Is it going to be a repeat of MEC 1.0? I guess now they're talking about MEC 2.0. We don't think so. I think, again, I agree with Vanch that this seems different this time around. I think that it's not a solution looking for a problem. There's definitely we can see some lead-in examples of where this is going to be needed. Is it here today? We don't think so.
Patrick, I know you're engaged with the AI RAN Alliance, so they're considering this idea of AI for the RAN, in the RAN, on the RAN. So I guess to the point around multi-tenancy of GPU accelerated compute at base stations, I mean, what do you think the kind of realistic outlook is over the next few years as we get towards 6G?
So in the standards, the work is being done now, and proof of concepts are emerging, and there are technical barriers that are being overcome. I'm not worried about the technicality. To be frank, I think running a multi-tenant compute capabilities, even with shared virtualized GPUs, is something that is happening, and there are progress that is being made in many areas. I think just like MEG, the issue has not been the technology; it's been commercial and mindset and operations. we're seeing, if we're talking about GPU as a service, we're seeing a sharp divide between our customers on their attitude towards that opportunity. Some of them say, listen, we're not going to be hyperscaler. We're not going to sell capacity as a service. That's not our business model. We're going to use GPUs and compute in our network to optimize our network and to provide customers with new services, but we're not going to do a wholesale scenario. Doesn't make sense. Others are a lot more ambitious and are thinking that they are going to be using or selling capacity as a service. And we see even the first implementations, mostly in Asia, in Japan, in Singapore, in Korea, where there are attempts to do that. And there are some use cases that are valid and that actually have commercial legs. I think the main issue is telecoms as an industry has been producing basically one-size-fits-all services for the last 40 years. Basically, the whole effort of telecom has been creating connectivity for the biggest amount of people with a level of service that is essentially the same across the board to acquire the most connection. Now we're moving into a new era, and the promise of 5G was to create basically connectivity services that would be differentiated by industries, use case, etc. Nobody said it, but in order to have that, you needed to have network virtualization, cloud native infrastructure, separation of hardware and software, 5G standalone, slicing. So we're just now basically seeing the capabilities that were promised in 5G starting to emerge. And if you look at GPU as a service, it's probably not something that you would deploy everywhere in the network, everywhere in the country. I don't know that it would be economical, and I don't know that you would have a use case that would justify that. But just thinking aloud, last week I was at a conference. You would think that venues like conference could offer services that would have a compute capability that would enable facial recognition for augmented glasses, for instance. And if my augmented glass had a LinkedIn layer, it would be very useful for me to, as I walk the alleyways, having facial recognition and my glasses telling me who I'm meeting and how to pronounce Inanç first name, for instance. So this is a silly little example, but there will be use case that will require compute that is close to where it is being consumed, and that is not going to be a permanent implementation. In those cases, why not have compute that is sold by someone that has excess compute, that is close by, and that has the capacity to deliver those services? So network operator will find a niche there. So, sorry, but your mileage will vary. I don't think we'll see, and maybe I'm wrong, but one use case that justified deploying compute everywhere in every network. But I think we'll see islands of implementation starting.
The middle path. All right. So, Inanç, I wanted to talk a little bit about AI ops. I know you all are very effectively using predictive AI for proactive issue resolution across your network. That has a efficiency boost for Veon, and it improves your customer experience, hits on churn reductions, a lot of benefits there. What other AI ops use cases are you all running at scale today? And what future use cases are you looking at that might require a little bit more maturity?
Yeah, let's start with one interesting use case that we achieved. We have done in Uzbekistan in one of our markets. We built a predictive net promoter score model that estimates customer perception before it turns into a customer complaint or churn action from the customer side. So how we basically do this, we combine survey results with the millions of geolocation-based network traces with the 70-meter sensitivity. And then we can actually, on the grid level, so we can map where experience is good, moderate, or at risk. So this allows us not only see the customer experience trends daily or hourly and per customer base, per subscriber, per customer. Also, it automatically generates some network improvement actions through the specific module, even simulate their impact, these actions impact in a kind of a digital twin scenario. And actually, I already said this, this is an ecosystem business, and it is not just us to achieve this. We work with a very strong partner which successfully combines network optimization and the network operation experience with the AI. So in our operation landscape in the AI side, if we split low-hanging fruits from the AI use cases and our operation pillar, which requires more maturity for the low-hanging fruit, I'm always saying that the first thing you should start with something simple thing which has been existing maybe more than a decade, like an automatic ticket resolution. This is a simple use case that you can easily actually apply this in the ICT operation and the network operation. Predictive maintenance, it is also low-hanging fruit. Energy optimization, it gives very good optimization results in your network and a very good cost reduction scenario. Traffic prediction, congestion avoidance, anomaly detection in the network side, and also anomaly detection in the cybersecurity. It's also one of the area that AI is very, very successful in it. And the intelligent radio network optimization, parameter tuning, and AI-driven customer intent categorization in your contact centers, in the call center, in your branch, or whatever your contact point is. It can be email, it can be just the call center call. Those are the low-hanging fruits, which gives you much of the benefits, and they're very easy to implement. And we are actually implementing and applying these in multiple markets in Uzbekistan, in Pakistan, in Ukraine, in Bangladesh, in Kazakhstan. And harder wins, which require more maturity from the ecosystem or from your internal organization. Of course, dynamic spectrum sharing using AI and the AI-driven orchestration. This is a little bit more tricky, and it requires more experimenting. AI native self-organized network. Its effect is enormous. It's a wonderful thing, but it is a little bit requires more experience and more experimenting. Closed loop automation with the data pipelines. Actually, starting from the beginning of the panel, we are talking about the importance of establishing the data and the data pipelines and the data governance, and to this automation of the real-time data pipelines. It really gives good and very, very great results in the production. And digital twin, I think this is the next big thing in the AI era, and we will be simulating every part of our organization. It doesn't matter, our internal organization, our network topology, or cities that we operate, we will be creating and simulating digital twins in that sense. And it looks easier to create cross-border AI learning loops between markets when you operate in the multiple markets, but it's also tricky because you have to very carefully adjust one experience from one market to another, considering some local factors. And another harder wins, but I think it is getting more and more, and we see more examples. Agentic network operation engineers creating agentic AI agents doing the network operations on your behalf. This is a little bit harder. This is a little bit tricky, but also it is one of the use cases which give the best of the result.
Excellent. Sridhar, question for you. Yesterday, we had a session with your colleague that manages the relationship between Google Cloud and Vodafone. And I think one of his key points was the distinction between buying access to compute and buying access to compute services support and an ecosystem of partners. So I was hoping you could maybe scan your telecom engagements and give us an idea of how that distinction is playing out in the real world. And I'd also append to this an audience question, role of AI in improving operators' security posture.
Yeah, so I'm glad you mentioned Vodafone, because it's a classic example of where it's not just about compute. As we scan the partnerships and the engagements we have across the telco landscape, I'll be hard-pressed to find a telco that's just a compute engagement. It's across the board. the whole ecosystem play, as you mentioned. If you take specifically the example of Vodafone, yes, we have our the core GCP services, compute, storage, network, and so on, but also the AI ops services, the Vertex AI modeling, and then we gotten SIs and ISV partners who would work with the data that Vodafone has. The data lake of different opcos from different data from different Vodafone opcos, and create different use cases, build machine learning models and create use cases. So it takes a whole village to get that going. And that's pretty much the case across all the telcos we have seen, even examples of where we have, this is public information with Verizon, for example, where they have implemented our customer engagement suite, which is our contact center AI solution. It's, again, Verizon, Google, and a few SI partners working together to bring the whole solution to market. In this case, it's an internal use case within Verizon. So, again, it's all about not just the services from cloud or Google. It's also the resources from the telco partner, and specifically ISV partners that have very specific solutions for those use cases. So it's a full service solution.
Right. And Patrick, we've talked about this throughout the session so far, but just the architectural decisions operators have to make. We've got AI RAN, we've got Open RAN, which you addressed earlier. There's a lot of sort of modernization investments going on in the second half of 5G here. When it comes to establishing a functional data architecture that aligns with an operator's business goals and where their network is today, can you give us some kind of practical advice on where you start with all of this? I assume step one is to identify your goal, but what's step two, step three?
You want to, as Inanç mentions, data pipeline and data governance is really important. You're not going to be successful in implementing AI at scale in your network if you don't know where your data is produced, where your data is prepared, where your data is being consumed. And so the first work is a work of discovery, and there are optimization at every step here. We spoke earlier about the fact that you might want to have basically a data infrastructure that is a little bit more performing, geared towards AI. So move away from spinning disk storage and go into a flash infrastructure. Importantly, you want to basically have a control plane for your data. And what that means is that there are software overlay that allow you to visualize where your data sets are in your network, where they're being produced, and that help with data mobility. A couple of years ago, Pure Storage acquired a company called Portworx that is doing just that by providing basically a container Kubernetes storage enterprise environment where you are able to visualize any data in your network in any storage. It doesn't have to be Pure Storage. Any storage that you have anywhere in your network, you can see what data set is where. And then when you know which data set is where, you can start looking at data mobility and data gravity and understanding which data should go where in order to be processed in what fashion. And then in addition to that, you have to be, Sridhar mentioned barriers to efficient data strategy implementation that are basically innate to telecom networks. Telecom networks have layers. Telecom networks have domains. And until now, those domains and those layers were pretty hermetic. So things that were happening there stayed there. And an AI operation of a network end-to-end requires to break those barriers. So Pure Storage launched a product at GTC a couple of months ago that is aiming to do just that, which is basically taking any data set anywhere in the network and laying it flat, as in allowing the preparation of the data, the cleaning of the data, and then the preparation of the data for the algorithmics to perform their work, irrespective of where the data is. What that means is that all of a sudden, let's say tomorrow you have an outage, or even not an outage, but let's say a congestion in a network location. Until now, you would get the alarms and you would look at those alarms and you would try to do something about it, but you wouldn't know really what the impact has been on customers. But being able to link the telemetry from the network, the radio network, telemetry from the transport and the core, linked with the OSS, BSS, linked with the customer profile and their location, all of a sudden you are able to say, okay, this event affected 10,000 connections. Out of those 10,000 connections, you had 6,000 connections that were actually active, where people were doing something. They were doing a call, or they were streaming, or they were on an app. Out of those 6,000 connections, you have X number that experience degradation of the service. And out of those, you have X number that are actual subscriber of mine, the other are roaming. And those subscriber of mine, out of those, you have 25% that are postpaid, and those that have been affected, that I know for sure by that event, I'm going to be able to propose them a video turbo for next month, for instance. So if you think about what is necessary to be able to do these kind of things, you have to be able to cross boundaries between the network state, alarming telemetry, the subscriber profile, the subscriber billing, their location, and what it is that they were doing when the event occurs. That's not possible, or that hasn't been possible until you are able to break the boundaries between the layers and take all the data in a state that allows basically pattern recognition to be end-to-end. And that's what we've been trying to help our customers with.
Here's a question for all of you. I think that the point's been made that AI is not new for telecom, but I think what is new is the pace of change in AI and the pressure from the board level, from the C-suite, to keep up, to go use AI effectively, to save money and to make money. So in that context, how do you all think operators should look at unit economics here when they're doing something brand new? How do you kind of do the financial modeling that goes along with that? And that would presumably help you prioritize use cases and pick which things to bring out of pilot into production first. Inanç, start with you, please.
Yeah, I mean, very simple. There are some areas that we see AI improves the profitability and triggers the cost reduction. Those use cases are related with the energy use efficiency, reducing the energy use with 10 to 20%. It is possible to achieve by AI. Managing your network OpEx through the predictive and the self-healing operation. Call center optimization, especially using GenAI and the LLMs. In your all contact centers and the call centers, you can create a lot of optimization. Even you can offload some of your the existing in-person call center capacity to the agents and the bots. Basically, they are performing really well with the good language models and the good agentic infrastructures. Hyper-personalization, it doesn't just reduce the cost, it also creates additional revenues and the additional ARPUs. And this is something everybody is looking at. I mean, the million-dollar question is, okay, AI is great for the cost-saving purposes, but where is the revenue? And the revenue is on the hyper-personalization side if you would like to achieve the revenue-generating AI models. Fraud reduction, it has been also in the place more than a decade. And another thing I already said, the digital twins and creating some simulation into your existing operational landscape, and creating a simulation, creating a kind of a digital twin, and to try something out there for the smart CapEx planning. Those are kind of the things that you can easily prove the return of investment. There are some other areas you should definitely avoid. The first thing is definitely long project cycles. It should be agile. AI is agile operation, and you should stick with the agile way of doing things, and you shouldn't be just the rounding around the 1 year or the 2 years of the project cycles. If you don't have a clear demand, over investing into the GPU is also the pitfall. You should avoid this. And running multiple AI silos inside of the organization, it is also triggering the higher cost, and it creates a lot of inefficiency. Large language models are great, but if you don't control the inference, it can create enormous cost into your user. So you have to have some kind of a cost guardrails for the inference of the large language models. And ignoring the data governance and not establishing the data pipelines, it also creates a multiple instance of the same data, and also not having a clean data at the hand, so leading rework and the operational drag. So you should also avoid this in order to prove the AI on the return of investment side from our perspective.
All right, excellent advice there. Sridhar, same question, and I mean, this speaks directly to how Google engages with telcos. You all have the scale and the breadth of offerings to kind of know what works and what doesn't, but just what would you add there?
Yeah, I think Inanç said it perfectly. It starts from an outcome. It starts from a KPI. It starts from a specific use case that has a business outcome already and an impact already kind of baked in. And so, for example, as I mentioned, call center optimization, we know that's clearly this clear metric about, take anywhere between 40% to 80% optimization in terms of not just the cost reduction, but as Inanç mentioned, revenue upside there. Those are clear business use cases that we know telcos across the board are leveraging AI for that. Same thing on the network side in terms of both anomaly detection and prediction and cost optimization. There's more of a cost optimization side on the network side. But again, there's very specific quantitative impact that we can talk about before we even start working on implementing this program. So again, it starts from take a use case, come up with a very specific KPI that you are bound to, and then start the project. And we are seeing that across the board, mostly from a network optimization point of view, and then a customer experience is all about call center optimization. That's really where the use cases are starting. The energy efficiency stuff that Inanç mentioned is also catching on for a lot of telcos. Again, that's a very specific metric in terms of energy consumption reduction, which is also a key metric for operational efficiencies. So these are specifically the use cases. One thing again on the thread of making sure that you're talking about use cases that has very clear impact that is measurable. Deloitte, who is one of our partners, they've come up with this nice tool that I think they call it the impact and feasibility tool, where before you actually go off and start looking at use cases to leverage AI for, you can look through your organizational processes and then kind of feed the data into this tool, and that the tool comes out with, okay, these are the different use cases that are ready prime time for being automated by AI, right? So I think those are some of the things that we're working with our partners to make sure that there is some scientific method behind doing this. And like Inanç said, not just go off, roll off multiple projects, just see what happens. It all starts with a very clear measurable metric that the teams are bound to.
Patrick, anything you'd add to that?
Yeah, two things. I think the first one is at the beginning of AI. Excuse me. We've seen a lot of operators, teams starting to play with AI, try new things, which is great because it favors innovation and people at the same time also are getting familiar with the capabilities of the technology. What it is not is efficient. And in many cases, most network operators, particularly the large one, have started curtailing that a little bit and basically put together AI factories in-house that are basically charged with providing the infrastructure and the capabilities to run AI projects. And then the internal teams become clients of this AI factory and submit projects for validation. And they're being categorized and prioritized. And as Sridhar confirmed, I think this is an innovation state, right? So no one has the recipe, no one has done it at scale and has demonstrated results that basically everybody's following. So everybody is doing their own thing and trying their own thing. And that leads to a couple of things. The first thing is, because it is innovation, you cannot just do a whole lot of planning and a whole lot of testing because it costs a lot of money and takes a lot of time, and because you don't really know what you're looking for, in the sense that you're going to need to be able to pivot. So being able to define your hypothesis that you want to validate and very quickly try to validate those hypotheses with real use cases allows you to pivot and fail fast, which allows you to discover also new hidden benefits. So that's one part of it. The other part of it is, large language models are great for universal things, language, sentiment, geography, etc. Now, telecom operators are networks that are all a little bit different. And those network operators that I see that are making the most progress in the use of AI are implementing their own small language model. Their own small language model that are geared towards understanding better the network functions, the network topology. They're using graph and neural network to be able to represent their network and to have those digital twins that we were mentioning, but also predict the state of that network over time. And in order to do that, basically, you need to create your own data set and your own representation of what should be the network and what it is, and measure variations of that. And that basically is culture, it's training, it's skills, obviously, so it takes a little bit of time, but those operators that have those capabilities end up having automation and optimization that are a lot more efficient because they're a lot more adapted to their particular needs.
All right, we've got 2 minutes left. We can go a little long. I wanted to pose one more question to the panel. Naturally, it'll be the most complicated one, but any technological transformation comes in parallel with the change management exercise. You all have addressed this. It's one thing to break down a data silo. It's another thing to decompose how your organization is structured. So maybe you could just give our operator audience some practical advice on how they need to think about the people perspective that comes along with getting AI right. Inanç, can we start with you?
Yeah, considering the time is short, I will be very, very fast. The upskilling everyone in the organization, because AI literacy is now like Excel literacy in 2000s, beginning of 2000s. Flatten the decision cycles. AI should accelerate the decisions, so organizations should also shorten the approvals and all the decision-making process. Building cross-functional AI squads. AI shouldn't belong to a single department, or it's definitely never a kind of a job of one IT department inside of the organization. Experimentation through that organization, and govern AI operation lightly but clearly. Ensure responsible boundaries, but without suffocating people at the innovation. I think those are the keys for organizational development perspective in AI.
Sridhar?
Yeah, again, Inanç said perfectly. Experimental culture, that's, I think, important for organizations to get the employee base to move and get along with the whole AI journey. And then taking gradual steps and progress towards a full automation, if you will, using AI, having the human in the loop also builds that confidence in the process. But again, it's all about the experimentation and the guardrails, making sure that there's clear guardrails in terms of responsible AI. How is responsible AI used and deployed within the organization, and make sure that everybody is on the same page as this is being deployed across the organization. Those are key.
Patrick, last word to you here.
I think you need two things. You need a centralized AI function that's responsible for putting the guardrails, deciding the architecture, the infrastructure, the governance, the pipelines, and then you need AI specialists that are embedded within the operations team themselves. Because there's nothing worse than a data scientist that is trying to figure out how to optimize the beamforming algorithm of a RAN sector without having any knowledge of how RAN works. And conversely, there's nothing worse than a RAN engineer that is trying to use ChatGPT to have a script on how to optimize its beamforming algorithm without understanding what ChatGPT does and how it does it.
Okay.
So you need both. You need to have embedded within the operations team people that have the data culture and that understand the domain. And then you need AI specialists and data specialists that basically define the domain of the possible, which is the infrastructure, the architecture, the flows, so that basically you have the best of both worlds.
All right, gentlemen, we'll leave it there, but I really appreciate you all joining us to have this discussion. And thank you to everyone that tuned in. We really appreciate your time and your attention.
Thank you. Thank you, everyone.
Thank you.